Where's my pen? Okay, there's my pen. Let's make a triangle. Okay. Okay, it's a right angle. And we're going to project 30 degrees. 30 degrees. Where's 30 degrees? Okay, 30 degrees, let's project it. Okay, this is 30 degrees. Okay, we want to compute for the force here. So what you do, just measure it. Measure it, this one, the distance. Measure this distance. Measure it, how many mm, and how many mm of this one. Let's try to use my caliper. No. Okay, let's measure it. Oh, this is just an estimate. You don't need to be very accurate. Okay, I measure about 64 mm. Okay, measure 64 mm, right? And this one, okay, 132. Okay, it's 132. So 132. Okay, 46 mm, 64 mm by 114 mm and 132. That's 90 degrees. Okay, the force exerted, the apparent force exerted here, the downward force, the x component force, will be equivalent to what? This will be equivalent to xf, equivalent to 64 over 132, right? 64 over 132. What will be that? What will be the answer? No calculator, so I have to use my cell phone. Oh, somebody text me. Okay, 64 divided by 132. 0.4848. 0.4848, is that right? Okay. 0.48. 0.48. So that will be a 0.48. This will be the force. Okay, so it's the actual force will be the force here, which we measure it. How much is the force here is 50 pound. 50 pound. And the downward force here will be 50 pound times 0.48. Clear, clear, clear. 50 times 0.48. 24. Downward force will be equal to 24 pound And the x force, which we don't need, okay? So we don't have to compute it. So we have actually computed the force will be 0.48 without using any scientific calculator. Actually, this will be, if you have a scientific calculator, it's much easier. All you have to do is just get the cosine, the sine function of 30 degrees. This is 30 degrees, the sine function of theta is equal to sine function 30 degrees, that's roughly 0.48. So this is a factor, 0.48. So the actual force we have computed will be 24 pound, 50 pound, this is 50 pound, 50 pound force. 24 pound force exerted on the apparent centrifugal force, okay, and the force under here, which we don't use. If you want, we can compute that. It will be 114 divided by 132, okay. 114 divided by 132. 0.863, right? 0.863. So the y force, 114 divided by 132 is equal to 0.8. What's that? 0.863. 0.863, or could be also the cosine. The cosine of 30 degrees. This is just a rough estimate, about 0.863. Okay, that's about it. So in short, this force will just compare for the purpose of this discussion. It's very we just break down this force into two components, the x component and the y component. So it's very easier to compute. Okay, so the force has been further dropped from 50 pound has been further dropped to 24 pound. So okay, so the force applied here is 50 pound. It's 50 pound. Due to the angle, it's further reduced to 24 pound. Okay, and one more thing, the surface area is further reduced because of the lower what do you call that? Lower force, so lower cushion. And the problem is there's no more lining, there's more glass lining, so there's no more cushion effect. So the metal is now touching the aluminum, so it will further drop the frictional force. Okay, that's about it. So without using any scientific calculator, this is just a rough estimate, but if you actually use it on a scientific calculator, it will roughly give you the same number. Okay, because the ratio of the opposite side over the hypotenuse is called a sine function. The ratio of the side length over the hypotenuse is a cosine, and the ratio of the opposite side over the adjacent side is called tangent. Okay, that's about it. So let me see your point. Bye.